Good afternoon. How's everybody doing? Title of this talk is Caching with MessagePack. My name is Chris Salzberg. I'm also known as Shioyama, or Shioyama Sensei. I am a staff developer on the Ruby on Rails infra team at Shopify. In that team, I'm in a smaller team called Rails and Core. Our mandate at Shopify is to keep the core monolith, Shopify's core monolith, basically the largest Rails production application in the world, keep that on tracks, keep that an enjoyable environment for developers to work in. The background for this slide is where I live, which is Hakodate in the north of Japan, in the southern tip of Hokkaido. It's a great place to go for those of you who don't know about it, and it would be a great venue for a future RubyKaigi, if the organizers are listening. Okay, so if the title of this talk seems familiar, that's because I gave a very similar talk at RailsConf a few months ago called Caching Without Marshall. There's overlap, there's a lot of overlap, but there are some differences. So if you've seen that one, this is still worth watching. Okay, so the starting point for this talk is an exception that was raised in production. This was about a year and a half ago now on the monolith. The exception was a name error, uninitialized constant beta flag service active record repository. I wasn't actually involved in the incident, but I was involved in the follow-up. So what happened was that this exception came up. It became an incident, required a rollback. So what happened basically, and if anybody who ships code knows this, when you ship code, you kind of, while you're shipping the code, you're dealing with two different universes, right? You're dealing with the universe before you ship the code and the universe after you ship the code. In most cases, these two universes overlap almost entirely. You don't usually ship huge changes in one shot. What happened in this case was that a refactor was shipped. The refactor was a refactor to a bunch of classes around beta flags, which are a pretty important concept in the core monolith. And so what happened was there was an instance of one of these beta flags things. It was wrapped in another thing, which was wrapped in another thing, and that final thing was then put into the cache. And then the old universe, which was still running as the code was being deployed, went to the cache, pulled it out, unwrapped it, got this beta flags thing, but all the class names and methods had changed. And so, of course, the old universe doesn't know what this is, and so it just blows up, and exceptions were raised all over the place, and then it was rolled back. So the problem with the situation is that we looked at this and we said there's only really two ways to fix or to deal with this problem. One thing is just you don't put so many things into the cache, right? If you don't put too much in the cache, then this can't happen. But that's not a great solution because then what's the point of a cache? The other solution is just you don't change code, because if you don't change code, this doesn't happen. You can write new code, but don't change existing code. But that's really not a good solution, and particularly for our team, we want to encourage developers to refactor and improve their code. So that wasn't a good solution either. So we started thinking, what is a good solution for this problem? And that's what led to this talk. So I want to first talk about caching as it relates to the topic here. In my RailsConf talk, I focused on the Rails cache, but since this is not a Rails conference, this is RubyKaigi, I want to focus on at a kind of a more general level. So in any kind of web application, you can imagine there are many things you might want to cache. You might want to cache actions, you might want to cache pages, or fragments of pages, or like results from the queries to the database, or responses from external API requests. These are all things that you can imagine wanting to cache. And then there are different places you might want to cache those things. For example, memory, file, Redis, memcached, many other places. And there are different ways to deal with this situation. One is to create caches for each type of thing. So for example, you could create a cache that would cache action type objects, right? And then that thing would figure out how to handle an action type object and create it, make it into a string so you could put it in one of these cache stores. And then you would create one for pages, you'd create one for fragments, right? And then you can see this would quickly get very complicated, not terribly scalable. So this is not what actually Rails does, and I imagine other frameworks as well. What Rails does is it has like one cache layer, right? And the one cache layer handles all types of caching. And so then the situation looks more like this. All these different types of scenarios where you might want to cache things, they all go to this one cache. And then the cache just throws those objects to the back end, whether that's memory or file or Redis or memcached. And then it's the responsibility of the back end to figure out how to cache this object that they've been given. And basically, universally, they all do this with Marshall. And if the flames are not obvious, there are risks associated with that. Marshall is obviously a very powerful tool. It's very easy to use in that way, but it has dangers. And the risks with Marshall are very well known. If you go to the documentation for Marshall, you can see that it says right there, especially Marshall load. So Marshall has two methods, basically, dump and load. Dump to serialize and load to deserialize. Load in particular has obviously security risks if you're serializing user-created data or something, or deserializing it. So these are well known. So you might say, well, let's look and see what Marshall is actually doing, and you could check the method and then try to look at the source. But of course, that wouldn't work because the source is not in Ruby, it's in C. And as far as I know, there's not really much information out there at all about what actually happens inside Marshall. So although this is a talk about MessagePack, I want to first talk about what Marshall does because we're going to have to try to reproduce that with MessagePack. So let's talk about Marshall. I'm going to use the same example that I used from RailsConf, but the details of application record are not important here. We just need an object that's big. So we have a post class. We create an instance with the title caching with MessagePack. We call Marshall dump, right? Two methods of Marshall, basically. So we serialize the data. This gives us back just this binary blob. When I did this a while back, it was 1,600 bytes. And you can see in there's constants. There are instance variables. There are values. It's got basically everything in there. But the magic, of course, with this is that you take that binary blob, you pass it to Marshall load. It could be a day later, or a week later, or a month later, or a year later, provided you haven't changed too much. And it will come back exactly the way you put it in, right? So it's like freeze drying it. You take it out of the freezer, it comes back to life exactly as it went in. So Marshall encodes the universe, right? It just takes whatever you put in, it goes all the way recursively down into this thing, ignores all concepts of privacy, and just encodes it. And this would be fine if our universe was static, but of course our universe is not static. At Shopify we ship many times a day, so the universe is constantly changing. And that combination of Marshall encoding the universe and the universe actually changing is really the risk here. So let's talk about what actually is in Marshall. So you can open up marshall.c, which is basically where Marshall is defined in C Ruby. And there's a bunch of constants at the top of the file which are revealing about what actually happens inside Marshall. So the first thing you'll see there is the major and minor version of Marshall. This hasn't changed. These haven't changed in eons. I've never seen them change. We treated this as a constant, so you can basically assume they're not going to change. This is not related to the Ruby version. There are next a bunch of things which I refer to as atomic. Basically, these are things that are kind of what you'd expect. They don't contain other objects inside them. So these are like nil, true, false, numbers, floats, symbols, and also classes and modules. There are also things which I'm going to refer to as composite. These are things that can contain objects within them. These are things like arrays and hashes and structs and objects, but also things you might not consider to be composite, like strings and regexes, so we're going to come back to that. And then also there's a bunch of stuff here which probably looks a bit mysterious. We'll come back to this. So first I want to talk about objects, the most basic thing. So this is represented by a type object, which is a small character ASCII O. If we take that blob that I had a second ago, we can convert this to hex. We get something like this. First there's the version number, as I mentioned. And then after that, you see there's the O for this is an object. There's a colon representing a symbol. So the first thing is the name of the class of the object. So it's represented as a symbol. The symbol has a length after it. That 9 means 5. So there's a compressed way of representing integers in Marshall. But basically that means length 4. So POST, that's the class name. And then there's a number of instance variables. And then you just have a bunch of instance variables, each one represented by the name of the instance variable, followed by the value itself. So in this case, the first instance variable is a symbol, new record, and the value is capital F, which is false. So this is not a new record because we created it. And then you've got all the other instance variables. And you can see how this quickly gets very big because each instance variable can be an object, for example, and have other things inside it. So this gets very big. Okay, the next thing that's important is variables. Objects can have instance variables, but other things that you wouldn't think of as having instance variables can also have instance variables. So for example, if we have a string caching with MessagePack here, you might not do this very often or ever, but you can do this if you want to in Ruby. You can say instance variable set, you can just set some variable, you can fetch it and Ruby will give it back to you. So if you put that through Marshall, you might not think about this, but what actually happens? Does Marshall actually correctly track that information? And in fact, the answer is it does. So Marshall basically tracks almost everything. And it does that using one of these types that I mentioned earlier, the weird ones. So this is a type ivar. It's represented by capital I, and that's used for tracking instance variables on things that are not objects, so other types of things that can't have instance variables. Okay, the next thing is kind of interesting. This is, these are links. This is like how Marshall handles circularity, basically. So very simple example of this, minimal example of this, you have an array, you put the array in itself, the thing is now circular, right? So you've got an array containing itself endlessly. So you notice that inspect handles this correctly, so it doesn't, segfault or something. But what happens if you put this into Marshall? Is Marshall going to handle that circularity, or is it going to segfault or do something weird? In fact, Marshall handles this correctly, or at least it doesn't blow up. And you can confirm that if you take the first element, it is indeed itself. So Marshall handles circularity exactly as you would expect it to. And that is because it has a type called type link, which is represented by an ampersand. And this is kind of interesting, so just quickly, this is like that encoded array containing itself. So 0408 is a version. You've got the array type, which is open bracket, the length, which again 6 here means 1, so it's a length 1 array, and it's got one element, which is a link type, and then basically it's like a pointer, right? The 00 points back to the first element in that object string. So it's a pretty compact and elegant format, I think. The last thing I want to mention is what I'm referring to as core type subclasses. So in Ruby, and related to Marshall, there are kind of 4 types of things which are a bit special. So those are hash, array, regex, and string. They're special because they're implemented especially in Ruby, and so Marshall has to treat them also in a special way. So if you subclass these things, like you subclass hash, for example, you have a myHash, you can create an instance of myHash. It looks like a hash, but of course, if you check the class, it's a myHash, not a hash. But if Marshall was just to serialize it as usual, it would take it, it would represent it as a hash, and it would come back a hash. So what does Marshall actually do? Does it actually come back as a hash or as a myHash? And in fact, Marshall handles this correctly, but it wouldn't work unless it had some special machinery to do that. And in fact, it does. It has this thing called type uClass. I don't know why it's called uClass. Maybe a Ruby committer can tell you, but it's represented by a capital C. And basically, it just attaches the class name to the hash data, so that when it brings it back to life, it knows that that thing is not a hash, it's a myHash. Okay, so why am I talking so much about Marshall? We're supposed to be talking about MessagePack. The reason I go into this detail is because within the cache, or in many contexts, we kind of throw a lot of things at Marshall and just hope that it comes back and don't really worry too much about it. But if you want to actually go and try to replace what Marshall is doing, you have to first know what Marshall is doing. So that's why I've gone into that detail. So now let's talk about MessagePack and how it relates to that. So I mentioned the problem we're trying to solve here is that we put stuff in the cache, it comes back in this case, the code before the deploy, and it blows up. This actually is a much bigger problem than this, because if your cache expiry, for example, is 2 weeks, any deploy in those 2 weeks can conflict with any other deploy in those 2 weeks, right? So it's basically a relation between the number of things you're changing, how long your expiry is, but it can be potentially a very big problem. So we want to have something in there that we don't have to worry about that anymore. It doesn't matter how long our cache expiry is. When we bring things out of the cache, they're not going to blow up that way. So we need a format that does not encode the universe. And for that, we use MessagePack, of course. MessagePack is an extremely efficient binary serialization format. It's a binary format, so it's similar to Marshall in that way. But the big difference is that, unlike Marshall, it is a generic format, so there are libraries for Java and Python and other languages. On the surface, it's very similar to Marshall in a lot of ways. So if I just give it a hash with a foobar kind of thing here, it will give me back a binary string. So this is similar. It's not the same binary string, obviously, as Marshall will give you, but it's a binary string. And if I throw that at MessagePack unpack, it will give me back the thing. So basically, pack and unpack are like dump and load in Marshall. The core types are also very similar to Marshall. So you have integer, nil, Boolean, like true, false, floats. So these are the atomic ones, raw, which can be string or binary, UTF-8 string binary. And then you've got the composite types, which are array and hash. So again, similar to Marshall. However, there is no object type, because this is not a Ruby format, so it doesn't know what object is. There is no instance variable type for the same reason. So this is good, because we don't want to start with serialization knowing what objects are, because then we have the same problems again. So just to kind of show you a bit detail how this works, with Marshall, we give it a string like foo. We get this byte string back. The foo itself is ASCII 666F6F, and you can see that appearing right there in the middle. And then there is, it's a string, and string is represented by quotes in Marshall. So that's 2, and then the length, which again, 8 is 3, so FOO. And then you've got this whole wrapper around this, and I mentioned this type IVAR, and this is a situation where it's used. This is actually a special instance variable. It's length 1, the name is capital E, which is used to represent encoding, and then the value is T for true. So this is basically saying this string's encoding is UTF-8. That's how Marshall handles that. So if we go to MessagePack, the first thing you notice is it's much, much shorter, right? You can see, again, that the same FOO is there, so 666F6F. And that's basically almost all of it, right? Like, you're literally just encoding the actual ASCII and almost nothing else. Partly that's because the UTF-8 is just default in MessagePack, so you don't need to actually put that in there. The other thing is that the type is very efficiently stored. So this A3 actually encompasses not only the type, but also the length together. So the first 3 bits, 101 says this is a string of length less than 31 bytes, and then the remainder says this is a string of actually 3 bytes. So it's extremely efficient. It's almost as efficient as you really could possibly be. So that's length 3. So we wanted to put MessagePack in. We started looking through our code base. We grepped for like Rails cache write, Rails cache read to see all the things that were going in. Of course, there's like tons of stuff that is not primitive types. So active record base is a big one. And then also objects, and also things that we don't even know necessarily what they are until we actually try. So we need a format that does not encode the whole universe, but that lets us encode a part of it. So this is actually a really killer feature of MessagePack, which is that, you can create what are called MessagePack factories. And so this is MessagePack Ruby I'm working in here, obviously. So you can create a factory, and then you can call a method called register type. Register type will allow you to register what are called extension types. And extension types are basically what allow you to extend MessagePack. So you give it a type, which is can be from 0 to 127, so there are 128 extension types. So here we're giving it type 3, so that's what MessagePack will use to encode this data. We give it a class. This actually will also match subclasses, so that's usually what you want, but you have to be a little bit careful with that. And then you define what's called a packer and an unpacker. And this is basically like the serializer and deserializer. So I'm going to show you what this is. This is actually an extension type that we use in production, the date type, and it's probably the simplest one we have, so I'm just going to show you that in detail. So here's the packer and unpacker. The packer takes a date object, returns a byte string. The unpacker takes a byte string and returns the date object. So here what we do is we take the date, we take the year, the month, the day. We call pack. Pack here is not a MessagePack method. It's an array method. You might have seen this. You basically give it a format string, and then it formats the data according to that string into the byte string. So here SCC is 16-bit signed, 8-bit unsigned, 8-bit unsigned, and that will give you back a byte string with that data in it. And then the unpacker just takes the same type of thing, calls unpack. Now unpack is a method on string, again, not MessagePack method, and it gives you back year, month, date, and then from that you can create an object. You create the date object. So I think that's pretty intuitive. And if we take today's date, September 9th, 2022, we can pass it to factory dump here, and it will return a binary string. And if we look at the binary string, it's this D603 is actually saying this is an extension type 3 object, and then E607 is hex 4 2020, and then 99 is September 9th. So we get back exactly what we put in. So it's pretty good. We can customize that. That's really, it was a killer feature for us to use this in production. The other thing, which is not really what you would think of as a feature, is the fact that MessagePack will basically blow up if you give it anything that it hasn't basically approved, that you haven't given it a type for. So if we put like an object inside an array as the key of a hash value or something like that, it will crawl the whole object, and if it sees anything that it doesn't know, it will blow up. It will blow up like this with a no method error, undefined method to MessagePack for object. It's not the most beautiful exception, but we can work with this. We can rescue the exception, we can check the message, see that it came from MessagePack, and that's exactly what we did. So let's talk about what we did. So this is now over, I think this is now over a year ago or so. We ran with MessagePack and Marshall alongside each other for a period of, I think, something like 6 months. I would not recommend doing this all in one shot. You gotta take it in steps. But the basic idea is like this. The puzzle piece here is some object coming into the cache. The cache we call factory dump. This is the factory that has all our extension types on it. If it works, then that's great. We put it into the cache. We prefix it with what we call a version byte prefix, which basically is something that tracks the extension types that we defined at the time when we encoded it, so that when we bring it back, we know what they were. And if it fails, we rescue the null method error, and then we just fall back to Marshall. And then the Marshall prefix, that 0408, that's how we know that it's a Marshall encoded payload. So this is what we did. And then the other way around, I'm not going to show you, but basically it's the same idea. You just look at the prefix. You can tell it's Marshall or not. If it's not, build a factory with those extension types, and then deserialize it. This is the actual, we don't have this code anymore because we're completely off of Marshall, but while we were transitioning off of Marshall, we had a rescue like this. And you can see we logged a lot of stuff. In particular, we logged the thing that failed. So in that example a second ago, we would log that object was trying to be serialized inside an array, inside a hash, right? So we want to know exactly where did MessagePack fail so that we can decide, is that something we need an extension type for, or is it something we shouldn't be putting in the cache in the first place? So when we started, Jean Boussier, who I work with on this, had already used MessagePack for some other work, so we already had extension types for a number of things. Symbol comes out of the box with MessagePack Ruby. You just have to enable it. But the other types we added, so there was time, date, which I showed you, and big decimal. And so this was our version byte prefix 00. This is what we started with. But very quickly, before we could even deploy MessagePack, we knew that we needed active record. And active record is a bit of a tricky one. I'm not going to go into too much detail, but the main thing, we needed to serialize the attributes of a record, but also we needed to serialize its cached associations. So it's loaded associations, right? If you already loaded some associations on a record, you don't want to load them again when you bring it back out of the cache. So in my RailsConf talk, I talk in more detail about this. I'm not going to talk in too much detail now, except that one of the problems is you have an inverse. If you have inverses, you have that circularity that I mentioned Marshall handles, right? Marshall will handle this. It will handle it not efficiently, but it will handle it. And so what we did is I created actually a coder which handles that and gives you back this set of arrays with the network of associations and the record attributes. And that's enough to serialize it all. And then we pass that to MessagePack, it serialized it into a string. And actually, when we looked at what the data was for a post with 2 comments with this scheme in MessagePack, we had about 300 bytes. Marshall was like 4,000 bytes, right? So this was like a 13x improvement. So the gains to be had on complex objects are really, really huge, actually, in space terms. And we actually could see this in production. So we saw a drop in our Rails cache fill percent that was actually quite noticeable. And with active record, we already were at like 95% or so. So we were already pretty close, but there was like a long tail of other things that we had to think about. The next one that we hit was this hash with indifferent access. Which, if you know Rails or active support, this is basically a subclass of hash, and it can deal with symbol or string keys interchangeably. So it's this is a core type subclass, right? Which I mentioned that Marshall will handle out of the box, so Marshall handles this, of course. MessagePack does not handle this. So if we just do this, if we take a hash with indifferent access here, we check the class here, it's hash with indifferent access. We can pack it, and then we can unpack it, and we lose the hash with indifferent access. So that's what happens out of the box with MessagePack. And that's obviously a problem. Our tests caught this, right? Always write tests. Luckily, our tests caught this, and we didn't ship this. And the problem, actually, I'm not going to have too many C slides here, but this is the problem in MessagePack Ruby. Basically, there's a switch statement, and there's an RB type, which returns the type of this object, but it will return a hash, whether it's a hash or a subclass of a hash. So it matches subclasses here. So the first response that I had with this problem was, OK, let's just create an extension type for this, right? So like I said before, we create a factory, we register a type. Here I register a type with number 7, and then I call it hash with indifferent access. And I need a packer and unpacker. Here I'm going to use the parent factory so that I can take the value, which is a hash with indifferent access, convert it to a normal hash, and then I'm going to dump it with the factory, which will then recursively go down into all its keys and values. And then the unpacker is the other way around. The value now is a hash. We know that because that's how we encoded it. We load it, and then we convert it to a hash with indifferent access. So this should work. It should work, but it didn't work. And this is in version 1.4.2 of MessagePack Ruby. The problem here is that the extension types are handled in this switch statement, in the default part of the statement. Unfortunately, the hash branch is hit first. So whether you define an extension type or not, it doesn't really matter because it won't even see the extension type. So this is my one and only contribution to MessagePack Ruby, but it's kind of an important one. I fixed this for both hash, but also the other three. So array, string, and regex. Previously, you could not encode subclasses of those because MessagePack extension types wouldn't work. Now the extension types work, so you can handle this. And this was like critical for us. We couldn't have shipped without this fix because we needed to encode those things. Okay, so we had that. We added some other things, active support time with zone. We were like 99% almost done. But then at a certain point, we were at this long tail, and we couldn't just tell thousands of developers, okay, you just add your extension types for whatever you need, because there are 128 max extension types, and we would hit that limit very quickly. So what we did is we defined a fallback, which is basically an object extension type. And almost everything is an object, so that basically catches everything. And then what we do is we just say, if the object thing has an instance method as pack and a class method from pack, we're going to consider this thing packable, and we're going to use the instance method as the serializer and from pack as the deserializer. And that allows developers to serialize whatever they want with MessagePack as long as they define those methods. We also defined some modules, for example, to make structs just serializable. It just automatically adds those methods to them. And then it also adds a digest such that the digest represents the attributes on the struct at the time that it was defined. And so if those attributes change, if it's okay, but if they change, it raises an exception. We catch the exception in the cache, and then we treat it as a cache miss. So it's basically a graceful way to handle transitions between changes in code. So with that, we got to 100%. That's where we are now. We have MessagePack in the middle of this picture. We basically don't have to worry anymore about these kind of problems happening, and that's really liberating for developers at Shopify. Most of what I talked about today has been extracted to a gem called Paquito. I want to give big thanks to Jean Boussier, who did all of the extraction work, and a lot of the other stuff I talked about we did together. So he really contributed a lot to this work. Thank you to the organizers. Thanks, everybody. Bye.